You are welcome again. Today we want to discuss measures of association. Yes. Under these measures of association, we want to understand the concept of risk and odds. Concept of risk and odds. Then you now understand risk ratio or relative risk. So that how is either you call it relative risk or risk ratio. It means the same thing. Relative risk or risk ratio, and the odds ratio, which is also called relative odds. So we run the risk ratio or relative risk and odds ratio with expresses, then interpret the result at 95% confidence interval. Just like the way we interpreted the mean difference at 95% confidence interval, we also interpret the odds ratio and relative risk at 95% confidence interval. So now, risk ratio, odds ratio. Let's talk about risk and odds. Risk is the same thing as probability. It's the same thing. So people think when they say risk, it has to do with something bad. Risk is probability of event happening. So it's probability. But because if something good happens, it's going to happen. The risk of probability of something bad happening. A few things of risk to be only probability.
And from
okay, volume. Okay, sorry. Okay, can you hear me very well?
Yes, Prof.
Okay, thank you. So risk is probability that a particular event or outcome will happen over time. And the relationship between risk and odds, risk is probability. So the relationship between risk and odds is such a way that odds is risk over 1 minus risk. That is, if the probability of it raining tomorrow is 6 over 10, which is 0.6, 60%. The probability of it not raining would be 1 minus the probability of it. So which is 4 over 10. So they are complementary. So risk and 1 minus risk are complementary. So let's say 70%, the complement is 30%. 80%, the complement is 20%. 30%, the complement is 80%. 50%, the complement is 50%. 60%, the complement is 40%. Does it make sense now? So risk is the probability of event happening. The complement of it is 1 minus risk. So if I say the risk of it raining today tomorrow is 0.6, the probability, the same risk of not raining tomorrow is 0.4. That's the remaining 40%. So the odds of it raining will be risk over 1 minus risk. That is 0.6 over 0.4. So that is odd is the probability of event happening over 1 minus probability of that event happening. And that is, or another way, probability of event happening over probability of event not happening. That is the odd. How much more happening is higher than it's not happening. That's all. So I will tell you, so if you want to the other way around, risk is odd plus 1 plus odd. But you may not even bother yourself much with that one. Let's look at the table on the right side. It shows you the relationship, further the relationship between risk and odd. Remember that probability is risk. If risk is 0, the odd is 0. You see, when probability is 0, probability can only be between 0 and 1. It cannot be less than 0, it cannot be greater than 1. But odd is from 0 to infinity. Can you see the difference? So look at that table. When the probability of event happening, the risk is 0.5. What is the corresponding odd? You can unmute and talk. It's a workshop. The risk is 0.5. What is the probability of corresponding odd?
0.05025.
Oh.
Okay, it's
From
1.
that table
It's
now,
1.
is 1.
It's
If
1.
when the probability, the risk is 0.5, the odd is 1. That is, if the risk is 0.5, that shows that the probability of it not happening is 0.5 also. What making odd will be 0.5 over 0.15 is 1. Anything over itself is 1. That's why 1. So if you begin to see as the risk probability increases, risk increases also. When the risk is 0.9, the probability the odd is 9. When the risk is 0.95, the odd is 19. When the risk is 0.99, the odd is 99. When the risk is 0.995, the odd is 199. When the risk is 0.9999, the odd is 999. Now, when the risk is 1, the odd is infinity. Because if you say, when the risk is, if you want to calculate the odd, you say, which is risk over 1 minus risk. So 1 over 1 minus 1. 1 minus 1 is 0. So 1 over 0 is infinity. Anything over 0 is infinity. So what it's telling you is that probability is from 0 to 1. That's the range of value. The range of value of odd is 0 to infinity. If when its probability travel is halfway, which is 0.5, the odd will be 1. When the probability completes the second half, the odd is infinity. Can you see now? So now let's move further. This is just showing the graph. I don't that one may be too much for you to all these other things, concept. But let's now talk about odd ratio and risk ratio. Relative risk, also known as risk ratio, compared to risk. When is it? It's comparing two risks. Odd ratio, which is also known as relative odd, compared to odd. So in what condition and why will you use odd ratio? Where will you use relative risk? In what situation will you calculate, say, I'm comparing two odd or I'm comparing two risk? Now, odd ratio is used when occurrence of an event. Okay, before I talk about that, I think there's something I need to, I don't know if okay, let me just use this table to explain it. You know, this odd ratio and relatively, they are called what we call measure of association. That is, when we did our chi-square, we just say there's a statistically significant, there's an association, but we have not quantified how much, what is the value of the association. P-value does not value the association, does not. It may appear that it doesn't quantify. It's only if the p-value is smaller, it means that the probability of it not being significant is of the finding not being due to chance is so small. That's what it means. It doesn't actually quantify it. But what the odd ratio and risk, relative risk does is to quantify. How do you quantify? You want to know, for example, now, when you have an exposure and outcome. For example, let's talk about people that smoke, people that have lung cancer. If you can divide people into you smoke, you don't smoke. That is your exposure. People that smoke, people that don't smoke. The outcome will be people that have lung cancer, people that don't have lung cancer. So in trying to look at the association between the two and quantify it, you can show it in a 2x2 table. And when you are showing the 2x2 table, the exposure will be along the route, and the outcome will be along the column. Look at that table you see. The people that are exposed, people that are not exposed, the people that have lung cancer, which is your event, and people that don't have lung cancer, yes, no. So you will see that it will give you four possible outcomes. We have usually laid bare A, B, C, D. A are the people that are exposed and they have lung cancer. D are the people that are not exposed and they don't have lung cancer. Those are the two concordant. We will now have two discordant. B are the people that are exposed, but they don't have lung cancer. C are the people that are not exposed, they have lung cancer. When we say exposed and smoke, A, people smoke, they have lung cancer. D, people that don't smoke, they don't have lung cancer. B, people that smoke, they don't have lung cancer. C, people that don't smoke, they have lung cancer. So you'll be able to, from here, you'll be able to calculate, okay, among the people that smoke, what percentage have lung cancer? That is a risk. Among people that are not exposed, what percentage have lung cancer? That is a risk. But you know that if lung cancer contributes to smoking, the percentage of people, the proportion of people that smoke that have lung cancer will be higher than the people that don't smoke, they will have lung cancer. So how do we quantify it? We will now quantify. We will now say, okay, since that is the case, we now divide the risk, which is the percentage, which is the risk is the percentage. You know its probability. You can say 60% means 0.6. So if the people that smoke that have lung cancer is 0.8, the risk among them is 0.8. And people that don't smoke but they have lung cancer, the risk is then 0.2. If you want to know how much more the lung cancer contribute to smoking, contribute to lung cancer, well, that's okay. Let's divide the risk among that smoking, because it should be greater. How much greater? We divide it by the risk among the people that don't smoke. So if it is 0.8, 0.2, I said it will give you 4. 0.8 divided by 0.2 will give you 4. It is not showing you that, okay, the people that smoke, they are 4 times more likely to have lung cancer than people that don't smoke. So by dividing, you are dividing two risks. That's what I call relative risk. That is the risk among the people that are exposed relative to the risk among the people that are not exposed. Are you seeing now? That's where the relative risk. So relative risk is divided two risks. The odd ratio is the same thing. We'll talk about it later, but just for you to get the idea, the odd ratio is a situation where you cannot calculate risk. The odd ratio, we'll calculate them now. We cannot calculate risk. Okay, maybe we just start discussing so that, because I want you to grasp it very well. Let's have a look at it. Odd ratio is used when occurrence of an event, e.g., incidence of a disease, cannot be calculated because the event has occurred in the past. You know, probability is about what will happen in the future. It's about risk of event happening. The event has not happened, but you calculate the risk of it happening. That is risk. But for odd, in a situation, where do you calculate odd? Where you cannot calculate it. For example, now, if you want to know the risk of having lung cancer, yes, you can say some people, they are smoking. You follow them up after many years. How many of them have lung cancer? But if you are trying to know the risk among the people that have lung cancer, you might have started Okay, you collect those people that have lung cancer, that are smoking, you follow them up. After some years, how many develop lung cancer? Calculate it. But in a situation, you want to do a study, the thing that's occurred, can you imagine somebody has already gotten lung cancer? You now say you are calculating the risk. Where will you get? It's lung cancer you are seeing. So where will you get people that are exposed? Because if you want to calculate the risk, it's people that are exposed, that are smoking, are able to contact. After a while, they develop lung cancer, you're able to calculate the risk. But if somebody, if you have, they already developed the disease, you cannot calculate risk. What you can do now is to calculate the horde. Horde is calculated, horde of smoking, horde of that event, that is horde of smoking among the people that have lung cancer. So we'll talk much about how you conceptualize it, but just know that that's the situation you calculate it. Then we use it in case control study. Case control study, the event has already happened. That's why you select cases. You now look for control that are not. So in trying to use relative risk and odds ratio to quantify association, you cannot use relative risk in a situation where the event has occurred, when the person is already having the disease. That's why it's only when we are doing case control, when we have the case, and we look for people that don't have the case, we want to find out, were they exposed to the factor causing the disease in the past. So in that case, we cannot calculate relative, we calculate odds ratio. We can calculate the odds for the two groups and now calculate the ratio. The same thing in cross-sectional analytical study. In a cross-sectional study, where you just do whether what is causing the disease or the disease, you just capture them at the same time. If you just go now, you say you are doing a survey of hypertension, you measure their hypertension, hypertension, you talk about obesity, you measure their body mass, they say these people are obese, these one are not obese. All those things, you cannot establish temporal sequence. You cannot tell us that, you cannot prove to us that those people that are obese, they were obese before they have hypertension. Some of them became hypertensive before they became obese. So you cannot establish that this is the risk and you follow up. No. So that's why in case control and cross-sectional study, that's where you can calculate. You cannot calculate risk. You now use odds ratio. So most statistical methods used for logistic regression also use odds ratio. So So for you to do, when you are doing regression, the odds ratio is with the statistics being used there also. Now, how can risk be calculated? Okay, but least before we talk about it, let's just look at this. Risk can be calculated only from data capture when the event has not occurred. So look at this, that's something that's a line now. The people at the top that are looking to the left, that's case control, retrospective cohort. There is a study that is, this thing has occurred, the event has occurred in the past. You cannot calculate risk. But this one, prospective, they are looking for, the event has not occurred. So these people that are looking backward, the disease has occurred, but the event has occurred, risk factor in the past before that led to the disease, everything in the past. But this one, we are looking at the risk factor now, but event has occurred. We are looking at the event in the front. That's where you calculate risk and compare risk between the people that are exposed and people that are not exposed. Let's look at, okay, I even explained there. That's what I came to explain the other time. You calculate risk and odds ratio using risk and odds using two contingency tables. Occurrence of event as a result of exposure to certain factors. The relationship between exposure to a factor and occurrence of an event can be depicted in a 2x2 contingency table, as you see. The row represents exposure to factor, while the column represents occurrence of event. Odds ratio for case control study, you see, I will not explain further here because I want us to use the example directly because I don't want to speak to here. Let's look at the example. So the first example now, I think it's about relative risk. In a study, 500 smokers and 1,000 non-smokers were followed up for 10 years to see how many will develop lung cancer. If 25 of the smoker and 5 of the non-smoker develop lung cancer, respectively, what is the relative risk of developing lung cancer following smoking? Look at it. It's very simple. Look at the 2x2. You use 2x2 contingency table. So you cannot talk about odds ratio and energy without that 2x2 contingency table. So the total is 1.5. 500 people smoke. Eventually, 25 develop lung cancer. 1,000 people did not smoke. Eventually, only 5 develop lung cancer. Can you see now? So you can calculate the risk for the people that smoke. The risk for the people that smoke now is 25 out of 500. 25 divided by 500. Can you see? So that's that A is that 25. 500 is A plus B. That 475 is the B. But when you have 25 to 475, that's what make up the 500.